No, that is not an optical illusion. That wall, specifically, actually the roof soffit, mostly you see it in the roof soffit, but also the wall, does have a bow to it. That's not supposed to be there. That's not an optical illusion. You can see how it's bowed out. So what would cause that? So here's your answer. Over here, these rafters are the ones a little hard to see, but down there, that's the wall that's pushed out. Those are the rafters where it's actually bowed outward. So this roof is not trusses. This is built with rafters. You got your rafters here. This is called a ridge board. It's not a ridge beam, it's a ridge board. The rafters are supporting the ridge board, not the other way around. The ridge board does not support rafters, even though it sort of does. The rafters are actually self-supported. So as the rafter's trying to push down on this end, that transfers weight to that rafter, which is transferring weight to that rafter across this ridge board. Through triangulation, that prevents it from going down. The problem is, it could slide down. So normally, these rafters are fastened to the ceiling joists. Now you see here, the ceiling joists, you can see them there. This whole end of the house, they're running with the rafters, as they should be. And normally, the rafters would actually be nailed into the joists. You can see they're not. That is why this roof has failed. So the rafters actually prevent the bottom of the triangle from spreading wider. In this case, because of whatever reason, it hasn't. Here, I can tell you why it hasn't. Because the rafters are running perpendicular to the ceiling joists. So over here, there's nothing tying this end of the house together. The only thing preventing that wall from bowing out other than the 2x4 top plate is the sheetrock, which doesn't do it. And you can see, if you look at it here, how that ridge board has sank, that rafter has opened up. This would have been up higher. That's why there's this gap here now, because the triangle widened. It came down like this. And it's a little hard to tell on the camera, but this ridge has dropped probably a good 3 inches. I haven't done the measurements, but so above a certain slope, you can do a self-supported rafter with the ridge board. Flatter than that, you have to have a ridge beam which supports the rafters. This is not a ridge beam, especially since it has these cuts and there's nothing actually supporting it. These kickers are causing more problems than they have fix. So it's I think it's right at the limit of what a self-supporting rafter with a ridge board can do. It might not be at that point, but we're also in snow country here, so it could have a 2-foot snow load, which further pushes on it. And then all these ceiling joists are running the wrong direction. Over here, this end of the house, things did not stretch out as much because you do have the ceiling joists running the right direction. But it did sag some, as evidenced by all these jacks they put in that were likely not original. And the weird problem with putting these in, trying to support the roof off the ceiling, because it's not designed for that, it's a little hard to tell from this angle, but you can probably see it from this angle. I don't know if you can see it on the camera or not. You can see kind of with that shadow there. Basically, the whole ceiling looks like it has waves running through it now. Because it's doing this because the ceiling joists are not supposed to be supported in the roof, and they are, so it's actually pushed it down in sections. You can kind of see it. That kicker in the middle, it's laying on a 2x, and it's bent that 2x4. So is this one. I gotta get some better lighting. Yeah, it's gonna need a little work. We haven't even gotten to that point with the customer. We're still on the foundation on this one. But that's gonna take a little work to fix. And I'm thinking I gotta do the math to see if, look up code and math to see if we can do self-supporting rafters with the ridge board. We may have to actually open this up, pull in about a 26, 28 foot long beam, like a glue lam, through here to support the roof and jack it up into position. Not sure yet. I haven't gotten that far down in the project. We're working from the ground up at the moment. All sorts of fun.